Week 8, problem 2, my program logic control class talks about creating a function block that produces a pulse width modulated output based on a 0 to 100% input value, which we have our percentage, which is our potentiometer. It's supposed to enable off, which is false, and the output must be off, which is going to be false as well. Pulse width modulation is a configuration diodes converting AC electricity to DC electricity and back to AC electricity. It can be used in applications to speed up or speed down a motor, having off and on times. So as you can see, we have our potentiometer at 0. We don't have an indication of a signal. If we move it to 20%, we get light on, and we are off for approximately 4 seconds, and then the light will go on again, creating that signal. If we go to 40%, we still have the same time, going from 5 seconds this time instead of 4. Then we get a light that switches on. So if we go to 60%, we get a light that stands longer. It stands on for 3 seconds, and it will stay off for about 2 seconds. So the higher the percentage, the longer the light will stay on, of course. As you can, if you get to 100, you will know the light will stay on, of course. If we go to 80%, the light stays on for approximately 5 seconds, and it'll turn off for only 2 seconds. And if we go to 100%, our light will stay on, which is pulse width modulation, because it is converting to DC, which is direct current and is always constant. And if we go back down in the potentiometer, it converts it back down to AC. As the seconds go back down to about 2 seconds for 80%, and as we're going to go for 60, that's what we expect in our problem. And as it indicates our signal going from true to false, as we look at our function block, we have indications of our signal going from true to false.